So we are looking at solving systems of equations today. And systems of equations, we're going to kind of review back on what we've done in the past with these. And in the past, we were doing just linear systems of equations. And so when to solve these, if they're already set equal to y, the quickest way to do it is just set them equal to each other. So we'd have 2x minus 5 is equal to x minus 1. And then since this is a linear equation, we want to get the x's on one side and our constants on the other. And so we'd have x is equal to 4. And then once we know what x is, we choose one of the two equations and solve for y. And so y is equal to 3. I want you to go ahead and do 2, 3, and 4. So in 2, you should have had 5x minus 6 is equal to negative 3x plus 2. So you would have come up with plus 3x on both sides, plus 6 on both sides. So 8x is equal to 8. Divide everything by 8. X is equal to 1. Choose one of the two equations. So 5 minus 6 is negative 1. So the ordered pair, therefore, is 1, negative 1. And then for the next one, again, set them equal to each other. Negative 4x plus 3 is equal to negative 2x plus 7. Add 2 to both sides, 2x to both sides, excuse me. And then subtract the 3. That gives you negative 2x is equal to 4. So x is therefore equal to negative 2. And I divide both sides by negative 2. And then we plug it in. And so we have y is equal to negative 4 times negative 2 plus 3. So 8 plus 3 is 11. So the order pair is negative 2, 11. Now the last one of this set is, we're going to set these equal to each other again. Subtract the x. And then subtract the 7 to get to the other side. And we have 2x is equal to negative 6. Divide everything by 2. X is equal to negative 3. And so when we plug it in, y is equal to negative 3 plus 1. So negative 2. So the order pair is negative 3, comma, negative 2. And so on all of these, when we were solving them, we came up with just one ordered pair that would work for both of them. But when we're dealing with what we've been talking about lately, which is parabolas, we're going to have other situations that could come into play. So we're going to be looking at the intersection of a parabola and a line today. So let's go ahead and think about this punter who's kicking the football. And when he kicks the ball, when we graph it according to time, it's going to follow a parabolic curve. And he didn't kick it from the bottom because he's a punter. Oops, that was a bigger eraser than I meant. So that means it's going to start somewhere up in the air. Now let's go ahead and take in the blocker. Let's not worry about the position on the field. We're just talking about how the hands are moving. So he's going to start from higher and come down. And will those two lines possibly intersect? Yes. There's a possibility that he can block the kick or the punt if he does it soon enough. So let's go ahead and graph it in your graphing calculator. So let's graph these two equations. Y is equal to negative 4.9 x squared plus 20x plus 75 hundredths. And so remember, when it's y, that's the same thing as that f1 of x. And then your f2 of x, we're going to graph that negative 6/10 x plus 3. And when you graph it, your graph should look something like this. And don't forget to set your window to match the window that's given here so you can see the details that we need to see, because you only need to see the first 5 seconds of that kick. As after that point, it's hit the ground. And so we're to think about this. These graphs touch twice. So this graph has two solutions. If I'm just looking at the graph alone, I see two solutions. But when I take into context the fact that this is a kick being punted, there's only one time that can be blocked. Because you're not going to block the kick here or the punt there. You're going to block it early on. So now let's just work through solving a linear and a quadratic system. So when there's a linear line crossing through a quadratic, what would the solutions look like? So step 1, let's go ahead and write the equation. So remember, we're just setting them equal to each other. And I like to have my x squareds on the left-hand side. You don't have to. So now that we have the equation, we realize that we have a quadratic, so that means that I need to use either factoring or quadratic equation to solve. And it seems like most of y'all this year in class have been going as default into the quadratic equation. This one can be solved with either because that a is 1 and it's actually going to work out nicely for either one. But let's go ahead and start working it up here. So I'm going to go ahead and bring it over here so I have room to work. So step 1 is get everything to the same side when you're working with anything quadratic. And so when we do that, we have x squared minus 2x minus 3 is equal to 0. So A is equal to 1, B is equal to negative 2, and C is equal to negative 3. And when we plug, the first thing we do when we have a quadratic equation is we want to find our discriminant. And so that's the b squared minus 4ac. So negative 2 squared minus 4 times 1 times a negative 3. So now that we have that plugged in, let's go ahead and find our discriminant. So when we find our discriminant, negative 2 squared is 4 minus, we have 4 times 1 times negative 3, so that's going to be plus 12, so 16. Now we're going to plug it into the quadratic formula. X equals negative b plus or minus the square root of your discriminant divided by 2a. So opposite b is 2 plus or minus the square root of 16 divided by 2 times 1. So what is the square root of 16? 4. 2 times 1 is 2. Now I can split it into its two parts. And so I'm leaving myself enough room when I do this. We're going to have two different things we have to do. And so we have x equals 2 plus 4 divided by 2, which is 6 divided by 2, which is 3. So we know one of the ordered pairs has a 3 for the x value. Now I need to find my y value. So I'm going to take one of these equations. I personally prefer to work with the linear equation. So y equals 2 times 3 plus 7. So 6 plus 7 is 13. So that gives me my y value. I know question B is just asking you for your x. If you want to fill it into that, all question B is asking you for is that 3. But I just go ahead and do it all at once, since I can't carry my screen over to the next page. So 2 minus 4 over 2. 2 minus 4 is negative 2. Divided by 2 is negative 1. Now I'm going to evaluate that into my equation for y. So 2 times negative 1 plus 7. So negative 2 plus 7 is going to equal 5. And so my other ordered pair is negative 1, comma, 5. And when you're writing these solutions, I just put a comma between them when you're listing them because they're both solutions. It's just a listing of the solutions. So again, the x's were negative 1 and 3. The y's, and where they matched up, was 5 and 13. And the ordered pairs were negative 1, 5, and 3, 13. So question 2 asks us, how can graphs of linear and quadratic equations intersect? So we can have that line and a parabola cross like this, and that would give us two solutions, which is two ordered pairs. Or we could have the line only touch that parabola one time, lose at the vertex, or it cuts through a different way. So we'd have one solution, which is one ordered pair. But the other way we can have them meet up is to actually not, where you have your parabola and the line not intersect, so it's no solution. When you're solving the problem and you come up with an imaginary solution in the quadratic, that's when it's no solution. So anytime you find your discriminant negative, you can just go ahead and stop and know that it's a no solution at that point. So we have them both equal to y, and that means I can set them equal to each other. And that gives me 4x squared plus 2x plus 5 is equal to negative 2x plus 4. Now I need to move everything to the same side. So add the 2x and subtract the 4. Add 2x, subtract 4. And I end up with 4x squared plus 4x plus 1 is equal to 0. Now I can use the quadratic formula. A is equal to 4, B is equal to 4, and C is equal to 1. And the first steps of the quadratic formula is to find that discriminant of b squared minus 4ac. And when I plug that in, I get 4 squared minus 4 times 4 times 1. So b squared is 16 minus 16 gives me 0. Now I'm going to plug it into the rest of the discriminant, or rest of the quadratic formula. So x equals negative b plus or minus the square root of my discriminant, all divided by 2a. Opposite of b is negative 4 plus or minus the square root of 0, all divided by 2 times my a, which is 4. So negative 4 plus or minus the square root of 0. So it doesn't matter whether I add or subtract 0. It doesn't change the number, so I do not need to write that. All divided by 8. And so I have negative 1/2 as my x. Now I need to find my y. So I'm going to choose one of these two equations to plug the x into to help find it. And so I'm going to plug it into the first one. Negative 2 times negative 1/2 plus 4. And so negative 2 times a negative 1/2 is a 1. Plus 4 is 5. And so this is one where it would only give me one solution because I didn't have two x values. So my one solution is negative 1/2, comma 5. So let's now work the b one. So again, we have y equals on both of them. So that means we can set them equal to each other. So 3x squared plus x minus 3 is equal to negative 4x minus 7. I again want to get everything over to my x squared side. So add the 4x and add the 7. And so we come up with 3x squared plus 5x plus 4 is equal to 0. Now we're going to plug it, we need to find our a, b, c, so we can plug it into the quadratic formula. Our a is 3, our b is 5, and our c is 4. So we're going to plug it into the b squared minus 4ac first. And so 5 squared minus 4 times 3 times 4. So 5 squared is 25. And 12 times 4 is 48. 25 minus 48 gives me 23. And a negative, because the negative 48 is larger than the positive 25. And so when I plug that in, we end up with a negative as our discriminant. So when we're plugging that in, that's going to go under our square root. So let's go ahead and plug it into the quadratic formula. Negative b plus or minus the square root of our discriminant over 2a. So opposite of b is negative 5. Plus or minus the square root of negative 23 over 2a. And a was the 3. So when we take the square root of a negative number, that's going to result in an imaginary solution. And which is going to mean that for the answer, it's going to be no solution. Because there's going to be no time that that line is going to cross that parabola. So again, if you get the imaginary solution, that means that the answer is no solution. So a system of equations consisting of two linear equations has how many possible solutions? Well, we could have one intersection. We can have 0 intersections or no solution. Or we can have infinite many. And if we have a system of equations that consists of a linear equation and a quadratic, well, we could end up with 2 solutions, 1 solution, or 0 or no solution. And we cannot have infinitely many like we talked about in class because there's no way that a line and a parabola can completely overlap.